alpha particles of charge q equals plus 2e and mass m equals 6.6 times 10 to the negative 27 kilograms are emitted from a radioactive source at a speed of 1.6 times 10 to the 7th meters per second. What magnetic field strength would be required to bend these into a circular path of radius 0.25 meters? And the E that they're talking about here is called the elementary charge. It's just the charge of either a proton or an electron, and it's defined to be 1.6 times 10 to the minus 19. All right, so a lot of stuff going on here, but it all comes down to magnetic force. And before I jump into that, I want to just give you what the definition of a magnetic field is, so we can start defining things for you. All right, so my definition of a magnetic field is what the force would be on a plus 1 Coulomb test charge moving 1 meter per second perpendicular to the field. It turns out that magnetic fields can only apply forces to objects that are moving. If an object's stationary, you get no force from a magnetic field. And I wanted to add this down at the bottom. It turns out that forces from a magnetic field are always perpendicular to that object's motion. And if that's true, if you have an object that's like moving to the right, but the force is going up, well, that's a centripetal force. We talked about that stuff before. So magnetic forces are always going to be centripetal forces. So it's very useful to kind of combine both of those ideas at the same time in a problem. So based on these two ideas, there are two equations that you can really conclude that are necessary to knock this problem down. So first of all, if the magnetic field tells you what the force would be if you have a Q of plus 1 and a V of 1, then this is kind of how the formula fits together. The force from a magnetic field equals charge times velocity times how strong the magnetic field is. So hopefully that formula kind of makes sense to you. And then over here, since I told you that all forces from magnetic fields are centripetal forces, then oftentimes it's going to be very useful to set FB equal to mv squared over r, especially when the magnetic force is the only force that we really care about in the problem, kind of like this one. So at this point, it's really just a matter of throwing numbers in. So I got kind of a big step that I took here, but basically over here, since I said that the magnetic force and mv squared over r have to be the same thing, then over in this formula, where there was a force of B, a magnetic force, instead, I'm allowed to write an mv squared over r. So we just substituted this over here to get a really nice expression for the relationship going on here. mv squared over r equals qv times b. And b is the thing we're interested in, so that's why I wrote it in a different color. And we want to get b by itself. Now, if you wanted to, you could have plugged in numbers right here and then solved for b. I think it's a little bit cleaner if you just get the b by itself, so that once you punch everything in the calculator, you're done. I think it's quicker, and it's the way most physicists tend to do things. They usually save the calculator till the very last step. But these two v's cancel in here, so you just get b equals this expression. And then it's a matter of throwing the numbers in. One last little tip. The way that I recommend throwing these numbers in your calculator to make sure you don't make any mistakes is if you want to, for the stuff on top, you can have parentheses and just go 6.6 e negative 27. And that's telling your calculator to do times 10 to the. I think it's usually second comma on your calculator. It might vary from one calculator to another. And then times 1.6 e7. Close the parentheses, and then we got the stuff in the bottom of the fraction. You probably know where I'm going with this. So 2 times 1.6 e minus 19, and then times 0.25. It's just a nice shortcut in your calculator, because if you have to type all this in your calculator, you're probably pretty likely to make a mistake in your keystrokes somewhere. So I highly recommend doing this. It's a little bit cleaner of a version. Let me get that number for you. When I tossed all that stuff in the calculator, I got 1.32, and the unit for magnetic field is Tesla. See you on the next one.